take this number here, which is 4. Okay. Now let's take 4 and let's square 4. Well, what's 4 squared? It'd be 4 times 4, which is 16. So what's the square root of that 4? Well, square root of 4 would be a 4. Okay? Well, it's actually plus or minus 4, but we'll get into that later. Well, when you take the square root of something that we're squaring, what we're left with is we're left with that piece there, right? Because what is the square root? You're looking for a number times itself, okay, to get that result. So if we're taking a number and we're squaring it, we're essentially multiplying it by itself. So if we take the square root of that, we are just ending up with whatever number we're starting out with. Okay? So, same is true if this is a 3, right? 3 squared, and then take the square root of that, end up with a 3. Okay? Take a 9 squared, take the square root of that, we end up with a 9. Take an x squared, take the square root of that, we end up with an x. Okay? So what if we have x squared equals 9? Okay? We can solve for what x is. The idea is we want x to be all by itself. We're isolating the variable just like we've done in the past. We want x to be all alone. Okay? Well, whatever I do to one side of the equation, as long as I do it to the other side of the equation, I'm not breaking any rules. Okay? So if I take the square root of x squared, so I'm taking the square root of one side of the equation, I have to take the square root of the other side of the equation. Okay? So the square root of x squared would just be x. And the square root of 9 is, I'm sure some of you just said 3. You're half correct. Okay? The square root of 9 is actually a plus or minus 3. Because what I'm looking for is I'm looking for two numbers. Okay? Or excuse me, I'm looking for one number that when I multiply it by itself, it ends up with whatever's under that square root. So if I take a positive 3 times a positive 3, I'm going to end up with a 9. And if I take a negative 3 times a negative 3, I'm also going to end up with a 9. So both of these answers are equally valid. So they both matter. The plus or minus 3 matters. Okay? So what if I have something a little more complicated? Say I've got x squared plus 3 equals 28. Okay? So I want to solve for x. I'm going to subtract 3 from both sides. I'm isolating the x term just like I've done in the past. I'm just going to have an extra step in the end. Okay? So this would be x squared equals 25. I take the square root of both sides. The square root of 25 is plus or minus 5. Okay. Let's do something a little more complex. So again, I want to solve for x. But this time, okay, what I'm doing here is I'm taking this x plus 3 and I'm squaring that. And I'm squaring x plus 3, right? This is x plus 3 times x plus 3. I can't just distribute that square to both of these pieces. If I do, I'm losing information. Okay? So I need to get rid of that square first. So what I'm going to do is I'm going to take the square root of both sides. Okay? So the square root and the square undo each other, and I'm left with x plus 3. Okay? Now I take the square root of 16, which is plus or minus 4. So now I've got two possible answers. They're going to be slightly different. The first one, x1, is what if x1 plus 3 equals 4? Solve for x. Subtract 3, x1 equals 1. I can check out this answer, make sure it works. 1 plus 3 is 4, 4 squared is 16. Okay? There's another possibility. I take x2 plus 3 equaling negative 4. So now I'm going to subtract 3, x2 would be equal to a negative 7. See if that works. Negative 7 plus 3 is a negative 4. Negative 4 squared is positive 16. So they both work.